Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. So we start with this one in the last class. We'll continue. This is the next question. I've shared all the images on WhatsApp, children. I think yesterday or day before, I don't remember. I shared all these images on WhatsApp. So I'll just explain them now, and you can write it down with the help of the images later. Now, this question is find the area of the rhombus whose perimeter is 80 meters. Now, we know that in a rhombus, all the sides are equal. In a rhombus, all sides are equal. In a square also, all sides are equal. In both a rhombus and a square, all sides are equal. Square, all sides are equal. Rhombus also, all sides are equal. The difference is that in a rhombus, the diagonals are unequal. Diagonals are unequal. Here in a square, diagonals are also equal. We learned this in the chapter quadrilaterals in detail. So in both a rhombus and a square, all the sides are equal. In a square, the corners are right angles. In a rhombus, the corners are not right angles. The corners are not right angles. In a square, the diagonals are equal and they bisect at right angles. In a rhombus, the diagonals are unequal but bisect each other at right angles. So they bisect at right angles. In a square and rhombus, the diagonals bisect at right angles. But in a square, the diagonals are equal, while in a rhombus, the diagonals are unequal. So this is just for your information, children. So these properties we learn in detail later. So since in a rhombus all the sides are equal, 4 into side, 4a is equal to 80. So a is equal to 20. All the sides are equal, no? So each side is equal to 20 meters. So each side is 20 meters. 20, 20, 20. And one of the diagonal is 24 meters. So any one, you can join any diagonal. This is 24, this is 24. Now it's so easy to find the area of the rhombus. Find the area of this triangle. The same will be the area of this triangle because see the sides 20, 20, 24, 20, 20, 24. Same sides, no? 20, 20, 24, 20, 20, 24. So whatever is the area of this triangle, the same will be the area of this triangle because the sides are the same 20, 20, 24, 20, 20, 24. So find the area of this triangle and double it. You will get the area of the rhombus. Is that fine, children?
Yes, ma'am.
Very good. Very good. So very good. You can see a perimeter of the rhombus is 80 meters. So 4 into side is 80, side is 20. Each side is 20. So when each side is 20, I think the diagram is missing. So you have to draw the diagram. This is missing. So now in the rhombus ABCD, we know that each side is 20. So 20, 20, 20 and 20. Okay, so this is 24. Yeah. So find the area of the triangle ABC using Heron's formula. The same will be the area of triangle ACD. You can see here. Whatever is the area of triangle ABC, the same will be the area of the triangle ACD. So the area of the rhombus is 1 plus 2, which is 384 meters square. Is it okay, children?
Yes, ma'am.
All right.
Yes.
Very good. Same thing here, children. A rhombus-shaped field. A rhombus-shaped field has green grass for 18 cows to graze. For 18 cows to graze, there's one field, and 18 cows have to graze in the same field. If each side of the rhombus is 30 meters and its longer diagonal is 48 meters, so side of the rhombus is given straight away. The side of the rhombus is given straight away. And its longer diagonal is 48 meters. How much area of grass field which will each cow be grazing? So, you just have to find the area of the rhombus and divide by 18. Assuming, that the each cow, no cow grazes more than its share. They're sharing the field equally. The grass in the field is shared equally among the 18 cows. So we assume that all the 18 cows graze only their portion. They don't eat more than that. So whatever is the area of the rhombus divided by 18 will be the share each cow gets. So we have to find the area of the triangle ABC. Area of triangle ABC. So find the semi-perimeter. Find the semi-perimeter, then find the area of the triangle ABC. We get 432 meters square. The same will be the area of this triangle ADC. That also will be 432. So the area of the rhombus is this plus this, 864. So each cow will get 864 divided by 18, which is 48 meters square. 48 meters square. Simple, right, children?
Yes.
All right.
Yes, ma'am.
Yeah, children. Right. Tanya has a piece of land which is the shape of a rhombus. She wants her one daughter and one son to work on the land and produce different crops to suffice the needs of their family. She divided the land into two equal parts. If the perimeter of the land is 400 meters and one of the diagonals is 160 meters, how much area each of them will get? So here there are two children, no? So you'll have to divide the area of the rhombus by 2. The perimeter is given. So 4 into side is equal to 400. So each side will be 100 meters. Then the diagonal, one of the diagonals is 160. So find the area of one triangle. The same will be the area of the other triangle. So each child. So actually here the question is how much area each of them will get. So each one. So if the son gets this one, the daughter will get this one. Because both have them, both the triangles have the same area, right? Both the triangles have the same area. So actually here they're not asking you to find the area of the rhombus ABCD. How much area each of them will get? So I have found the area of the triangle BCD. I found the area of the triangle BCD. BCD is 4,800. So that means each of the two children will get an area of 4,800 meters square. Because we'll have to answer the question. No, we need not find the area of the rhombus. How much area each of them will get? So each of them will get 4,800 meters square. There's 4,800 meters square here for the boy, and there's 4,800 meters square here for the girl. So each of them will get 4,800 meters square. So here it's enough to find the area of one triangle. Both the triangles have the same area. So one triangle for the son, the other triangle for the daughter. All right. You have to work this, children, because see, maybe if it's very simple, you don't have to copy the question and spend time. Okay, you can just give the reference number from your NCRT, or if you feel the question is really easy, you can just ignore writing the question. But you have to practice the answer, because see this here, how to simplify this. 180 into 80 into 80 into 20. So what have I done? I have not disturbed the two 80s. I have not disturbed the two 80s because 180 will come out. Then what have I done with this 180? I've written this as 20 into 9 because there's a 20 here. So I write this as 20 into 9. So from two 20s, 120 will come out. From two 80s, 180 out. And the square root of 9 is 3. So at least you should go through. Even if you feel, no, it is too simple to work also. If you feel so, fine. I'm not saying don't work. You can discuss with your parents. Maybe you need not work because it's just about calculating or number work. But you have to look at all this, how it is calculated. This portion is important. So I've not disturbed the 80s. 80, 80 as it is I've written. And this 180 I've written it as 20 into 9. Why 20 into 9? Because there's 120 here. So now there's another 20. So from the 220s, 120 comes out. From the 280s, 180 comes out of the square root. And square root of 9 is 3. and the product is 4,800. So please at least go through the working. All right. The sides of a quadrangular field. The sides of a quadrangular, meaning quadrilateral, triangular, meaning in the shape of a triangle, quadrangular, in the shape of a quadrilateral. The sides of a quadrangular field taken in order. So the sides are these. I'll just take some rough figure like this. The sides are 26 in order. See, in order means you should write 26 here. You must not write 27 here and 7 here and 24 here like this. Order means you must fill the sides in the clockwise or anti-clockwise direction. In order, it's always in order, even if it is not mentioned. See, if you start 26 here, you can write 24. See, okay, let me draw it again. Okay, supposing you start 26 here. The next number is 27. You can write 27 here or here. That is fine. But supposing you write 27 here, then 7 will come here only. You cannot write 7 here. 7 has to come here and 24 has to come here. So in order, 26, 7, 20, 26, 27, 7 and 24 in the clockwise direction. In the clockwise, like the hands of the clock move. Clock like this only they move. No, they don't go like this. They don't go in the reverse. Do the hands of the clock go like this? No, they don't go like this. They go like this. They keep going like this, round and round like this. So this is clockwise direction. Anti-clockwise is in the reverse order. Reverse. This is anti-clockwise. This is anti-clockwise. Okay, so that's very important. So if you mark 20, supposing you mark 26 here and you mark 27, say here. So 26, 27, so 7 goes here only and then 24 here. So 26, 27, 7, 24 in the anti-clockwise direction. So be very careful with that. So I have always told you, first you just draw, a quadrilateral that looks like a square or rectangle. Simply draw this and first write on the information. So 26, 27, 7 and 24. Okay, so these are the sides. You can even name it A, B, C, D like this. Then the angle contained by the last two sides. See, the sides are AB, BC, CD, DA. These are the last two sides, CD and DA. See here, CD and DA. These are the last two sides. These two sides contain a right angle. The angle contained by the last two sides is a right angle. Last two sides are CD and DA. CD and DA. This one is 90 degrees. CD and DA, they contain a right angle. This is 90 degrees. So now what we do is, now we'll modify the figure. So 7, no, 7 is small. So like this, and this is 90. So like this 24, and 26 is longer. So you can go like this, and maybe you can just join it like this. A rough figure. It's, see, when you actually construct it, it may look different. We cannot do the real construction here. Simply a rough figure. So now so first I draw this. First I draw this and I mark the information. And then I just get, I get a better idea to draw the rough figure. Once I do this, I get a better idea to draw the rough figure. So then this is my rough figure. A, B, C, D, I go like this, A, B, C, D, and then I mark 7 here, 20. The same thing. You can't change anything, the same thing. And this one is a right angle. Now, Tanishka, which diagonal will you connect? Which diagonal will you connect, Tanishka? Krishmika Shri, which diagonal will you connect?
DB.
DB, is it?
Yes, ma'am.
Okay. How many of you say she's right? What about the others? AB or AC or DB?
Ma'am, I think it's AC, ma'am.
AC. Danya?
Yes, ma'am, it's AC, I think.
Okay, the rest of them, Tanishka has not answered. The rest of them say AC. Now, Krishmika, if I tell you that your friends are right, can you correct yourself?
Yes, ma'am.
Yeah, your friends are saying AC. Why do you think they're saying AC? Why do you think they're all saying AC, Krishmika?
Ma'am,
Yeah. No problem. So I have told this earlier. Okay, tell me in my words, tell me children, one of you tell me, what is that I say? Why should you not connect DB? Because
it divides the right angle into two parts, ma'am.
no, I use a particular term. Can anybody recall that? You should not dash the right angle. You should not.
Bisect.
No. You should not dash the right angle. You should not. That's what I always. You should not what?
Dash the right angle.
No, that's not the term I use.
Divide, ma'am.
Divide, no. See, when our teachers used to teach us, certain words which she used, we'll recall the answer with the words the teacher uses in the class.
Ma'am, separate.
No, I've used it so many times because when we started Heron's formula, we have, I gave you sums like these, meaning we understood sums like these. I think 2-3 cases. This one we must have done earlier. Then the PPT was not ready. At that time when I started, the PPT was not ready. Okay, I used to say, or earlier I've told you that you should not disturb the right angle. You must not disturb, don't disturb the right angle. When you join the diagonal DB, you're disturbing the right angle. So now the right angle is not completely in any triangle. The right angle is not completely in any triangle. You have disturbed it. So join that diagonal which does not disturb the right angle. So when you join the diagonal AC, you are not disturbing the right angle. The right angle is in this triangle ADC. Okay. Now next, what do we do, children? Sindhu, what do we do next? After joining AC?
Ma'am, we have to find the area of triangle ACD, ma'am.
Yeah, formula.
Half into base into height.
Half base into height, half 7 into 24. So you got the area of triangle ADC. Next, Sanjay, next.
Ma'am, we should find the area of BC, ma'am.
ABC, very good. Yeah, we should find the area of the triangle ABC. Yeah. Using?
Ma'am, Heron's formula, ma'am.
Heron's formula. What are the sides of the triangle?
Ma'am, 27, 26, and we should find AC using Pythagoras theorem, ma'am.
You should find AC using Pythagoras theorem in which triangle? You should use
ADC.
ADC. You must use Pythagoras theorem in triangle ADC and find AC. And then find the area of triangle ABC using Heron's formula. Very good. So that's what you see here, children. You can see the figure which I explained. You should find the area of this triangle using the formula half base into height, which is 84 meters square. See, I'm pausing so that you see what is on the screen. You must be quick. I am giving you time. See, after I say no, even I'll look at that, look at this. So that's how I count that you need that much time to, read this and this. When I'm talking, I'm both a mentor and a student. Because I have to gauge, how long you need to look into that. That's why I pause. When I pause, don't wait for me to continue. You're supposed to look at the screen and understand. So we first find the area of triangle ADC. So here you can see half into base AD into height DC. Then we need to find AC using Pythagoras theorem from this triangle ADC, because that's a right triangle. So you can see the calculation here. AC is 25. Now we need to find the area of triangle ABC using Heron's formula. You can see here. And the area of the quadrilateral is equal to area of this triangle plus the area of this triangle. The area of the quadrilateral is equal to area of triangle ADC plus the area of triangle ABC. Krishmika Shri, why should we not join the diagonal DB?
Ma'am, because if we join the diagonal, it will disturb the right angle.
Yeah, the right angle is disturbed. So you must connect the other diagonal, AC.
Yes.
By connecting AC, you're not disturbing the right angle.
Yes, ma'am.
Very good. So here, children, similar to the earlier one, but the angle contained by the first two sides of the right angle. Children, there's a repetition. We've already done these sums earlier. Okay, the first two sides is the right angle. Okay, so let's see how to mark that. So you can, take the values anyway. So like 5, 12, 14, 15. So don't worry about this. See here, I've done it in the clockwise direction. 5, 12, 5, 12, 14, 15. Okay, like this I've gone. Okay. Simply just take a figure like this and 5, 12, 14, 15. Okay, you mark it A, B, C, D. See here. AB is 5. This is the first side, AB. This is the second side, BC. This is the third side, CD. This is the fourth side, AD or DA. So see here, the first side AB is 5. The second side BC is 12. The third side CD is 14. And the fourth side AD or DA is 15. Now the angle contained by the first two sides is a right angle. The angle contained by the first two sides. Which are the first two sides? AB and BC. AB and BC. AB, BC. AB, BC. This is 90 degrees. AB, BC. This is 90. The angle contained by the first two sides is the right angle. This is 90 degrees. So now let's draw the figure again. So AB is small, no? So like let's make it like this. BC is, this is 90 degrees, so it has to come straight like this. Okay, and CD, it's 14, it's longer. So let's go a little away like this. And DA is 14, so you'll have to connect something like this. So A, B, C, D, 15, 14, 12, 5. Krishmika, which is the right angle? Angle A, B, C, or D? Where is the right angle?
Angle ABC, ma'am.
Angle ABC. This is 90 degrees. Very good. Now, which diagonal should you connect?
AC, ma'am.
Very good. See, you got it. Should connect the diagonal AC. Then next, what will you do, Krishmika? You should find the area of. The question is to find the area of the quadrilateral.
Yes, ma'am.
Yeah. So first, what will you do? You'll find the area of triangle.
ABC.
Formula.
Pythagoras theorem.
No. To find the area, the formula is half base into height.
Half base into height. Sorry, ma'am.
Yeah. So half into.
Base into height.
Yes, darling. Values.
Half into 5 into 12.
Correct. Then you should find AC using Pythagoras theorem.
Yes, ma'am.
And then you should find the area of the triangle.
ADC by Heron's formula.
And then what will you do to find the area of the quadrilateral?
We'll add the two areas, ma'am.
Very good. That's all. Yeah. So just so you should now identify which part was difficult for you. So if this part and this part was difficult, you should concentrate on this. So now you should make use of this, or anybody who finds it difficult must make use of this opportunity, this question and this answer to understand this clearly. We shouldn't keep repeating the mistakes. All of us make mistakes, but when we get a chance to correct it, we must correct it for good. Should not repeat it again. So half base into height, this part you need to concentrate and then find AC using Pythagoras theorem. Okay, very good. So that's what is here, children. You have a test coming up. Maybe I'll teach till 8 o'clock and then you have a test. Children, see, because I've already done this earlier, I'm just explaining it like this. Is it useful? All of you following?
Yes, ma'am.
Yes, ma'am.
All right. Same thing, children. Angle contained by the first two sides is right angle. Now you should not worry that, you know, I don't know how to make the diagram like this. We can't do everybody cannot have this rough diagram. All of us cannot have this rough diagram. I told you how to make the rough diagram. All our diagrams will look slightly different only. So don't worry about the rough diagram. The shape of the shape should be a quadrilateral. But how it really looks like really doesn't matter for the answer. All of you will, if you work it correctly, all of us will get the same answer. The diagram will look different. But when you're marking, I told you, you should always go in the clockwise direction or anti-clockwise direction. So like 9, 40, 28, 15 like this. If you do some, like Gadbad and marking these, if you mark 9 here and 40 here on the opposite side, you mark 28 like this and 15 like this, then you're wrong. That marking is important where the right angle is between the first two sides or last two sides. You should mark the right angle correctly and then connect the correct diagonal, and the rest is the same. In this question also, children, we are given everything. That is, you're given in the quadrilateral ABCD. Okay, let's make the figure alone. In the quadrilateral ABCD. So quadrilateral, right? So see here. Here it's like this. Now, you need not draw it like this. You can just go something like ABCD is a quadrilateral, right? So first, as I told you, just draw a square like this and mark it as ABCD. ABCD. So for the rough diagram, we are drawing a rough diagram. There is a rough diagram to help us work the answer. For that, to make the rough diagram, we are making a rough diagram. That's what it is. So this one is, you can just erase it after you make the real rough diagram, After you make that real rough diagram, you can just erase this. So ABCD and then 7, 6, 12, DA is 15, AC is 9. AC is 9. Okay, now you should just, try to make a rough diagram using this. So AB7, AB7. Then just go like this. BC is 6, so let's make it small. Then 12 it is, so let's go longer like this. And then 15, so like this. That will be slanting. So it's not right angle, no? It's not right angle. So let's do like this. We'll do like this. We'll do. So just make it more slanting. Something like this. I've drawn this figure keeping the length of the sides in mind. See here, I'll just do it again if you want. So this is the real rough diagram. This is a real rough diagram. AB7, na, so I just went like this. Little I made for AB. Then BC is 6, so it's not 90 degrees, no, so you can't go straight. It's not 90, so you can't go straight. So something like you can go like this also. I simply went like this. 6. I went like this 6. Then 12. So I went like this 12. No, it's not 90 degrees anyway. So 12, I went like this. And then when AD is 15, that's still longer. So I went like this. Oh my God, they're not meeting. So what I did, I just came back. I erased this one. And I connected it from here to here. Like this, I connected it. That's all. So now mark A, B, C, D. Then this 5, 15, 12, 6, 7. And the diagonal AC is 9, like this. That's what you can see here also. So you don't have to get this exact figure. This is your figure. This is your figure. Or you may have it a slightly different way. That's fine. Information should be, written correctly on the figure. That is very important. So now what you see here in this triangle, the sides are 6, 9, and 7. In the other triangle, the sides are 9, 12, and 15. So for both the triangles, you have all the 3 sides. This triangle, you know the 3 sides. This triangle also, you know the 3 sides. So find the area of both the triangles and add to find the area of the quadrilateral. So we have found the area of the triangle ABC. Found the area of the triangle ABC, this one. Then we found the area of the triangle ACD, this one. It won't be the same, children. In the rhombus, we said whatever is the area of this triangle is the same as the area of this triangle. That's only in the rhombus. Here you can see the sides are different. This triangle, it is 6, 7, and 9. This triangle, it is 9, 12, and 15. Obviously, the area will be different here. Should find the area. Don't say whatever is the area of this triangle is the same here. No. So find the area of the triangle ABC, ADC, add both to find the area of the quadrilateral. Now you will ask me, how do you know root 110 is 10.488? Normally this value should be given in the figure. If it is, sorry, given along with the question. If it is not given, you should know to find the square root using long division method. You should know how to find the square root using long division method, 8th standard. So like that, we get 10.488. So if you don't know, I think I've already shared a video on how to find the square root. You can watch that. But I'll again send it today. So 110.0000. Find the square root. So that way we get 10.488. Yeah. All right. Same thing, children. Let's not spend time on this. Same thing. Actually, the same thing here also. Okay, you just have to compare. Finding area is the same. Who's claimed more, area? That's all. You'll understand. Anyways, you have the working, you can just go through and understand, but finding area is the same. Again, like we did earlier, all the sides are known to us. You can find the area of this triangle and this triangle. 3, 4, 5, 4, 5, 5. You know all the sides of both the triangles. So find their areas and, add both. See here, what I've done is I've used the converse of Pythagoras theorem for this triangle. See your children, you can find the area of this triangle ABC using Heron's formula also. You will get the same answer. You will get the same answer 6. Look at this triangle, children. Look at this triangle ABC, ABC, ABC. Okay. So this is how we use the converse of Pythagoras theorem. In this triangle, listen to this one. In this triangle ABC, which is the longest side? What's the length of the longest side in triangle ABC?
5 centimeter.
5 centimeter. That is AC. Square that separately. AC squared. Square that separately. 25. Which are the remaining two sides of this triangle?
4 centimeter and 3 centimeter.
AB and BC. So find AB squared plus BC squared. That is, find the sum of the squares of the remaining two sides. Square the longest side separately and find the sum of the squares of the remaining two sides. See, we are talking about this triangle. We are talking about the triangle ABC. If you remember in 8th standard, we know that 3, 5, 4, 5 form a Pythagorean triplet. That means they form the sides of a right triangle. The numbers 3, 4, and 5 form a Pythagorean triplet. So 3, 4, 5 form a Pythagorean triplet, meaning they go to form the side of a right triangle. 5 is the longest side. So square that separately. AC square 25. The remaining two sides are AB and BC. Find the sum of the squares of the remaining two sides. Find the sum of the squares of the remaining two sides. So 3 square plus 4 square. 9 plus 16, 25. They're the same. So you can see that AB square plus BC square is equal to AC square. You can see that AB square plus BC square is equal to AC square. So that means by the converse of Pythagoras theorem, angle ABC is equal to 90 degrees. Now, how do we decide this angle ABC is 90? Because the longest side is AC. AC is the longest side. So by the converse of Pythagoras theorem, the angle opposite to the longest side is a right angle. The angle opposite to the longest side is a right angle. So the longest side is 5 centimeters. So the angle opposite that is a right angle. So angle ABC is equal to 90 degrees. So then I found the area of this triangle using a half base into height because it's the right triangle. No, so half base into height, half into 3 into 4. 6 centimeters square. So you will think, why so much? We can directly find using Heron's formula. No, 3, 4, 5, so easy. We can do. This is just to recall that idea for you. How to use the converse of Pythagoras theorem. That's all. You can always find the area of this triangle, using Heron's formula. You can always find the area of this triangle using Heron's formula. The sides are 3, 4, and 5. Find the area, you will get 6 centimeters square. So I have just, expressed as to how to use the converse of Pythagoras theorem to show that a triangle is a right triangle. So if at all you feel that 3, 4, and 5, form a Pythagorean triplet, and you want to check if they are the sides of the right triangle, then what you should do is, just a second, children. Yeah, so if at all you feel that, this 3, 4, 5, that somewhere in 9th standard, you have seen that it's a Pythagorean triplet and you want to check if it is a right triangle, this is what you should do. This is what you should do. So whenever you come across something new, you should try to use that and find the area. So by practicing that, that will become very simple. First time when you see it, no, it might be like, why all this, roundabout, I can directly find it using Heron's formula. Something which is already simple for you, why do you want to practice that? That you already practiced and you have made it simple for you. Now, if you come across anything new, practice that and make that also simple. With practice, everything will become simple. So it's that practice which you need. Nothing is difficult. Anything that you don't put to practice will always be difficult. So when the days when I started cooking, I used to cook for that long. I used to go on. I used to make breakfast till lunchtime, make lunch till dinner time, literally like that. I used to take a long, not really like that, but somewhat like that. I used to kind of slog in the kitchen the whole day. In the earlier days, like when I was very newly married, I used to have no time for myself. Everything was very tedious and, time consuming. So as you keep doing it, when you keep, so then, you get to do it every day, every day, every day, every day. Now it's like 2 hours, I can make 3 meals, whatever it is, whether it is elaborate or whatever it is. 2 hours, all 3 meals done. Breakfast, lunch, dinner is ready in 2 hours. So I planned the earlier day, what I have to do the next day, and it's all done. It's very simple now. But when I started, it was so difficult. I was like, how do I do it? I'm always in the kitchen. When you do it regularly, that interest is also there. Everything is easy. It's so easy now. Oh, that's all. So like that, everything comes very easily by practice. Nothing on earth is difficult. You need to understand it clearly first. Once you've understood it clearly, then with practice, it becomes easy. Yeah. All right. So if this is new to you, then practice this one. Make this easy. Okay, so I repeat, if you feel that these 3 sides form a Pythagorean triplet and you want to show it's a right triangle, square the longest side separately and then find the sum of the squares of the remaining 2 sides. We get the same answer. That means, so since AB square plus BC square is equal to AC square, by the converse of Pythagoras theorem, angle ABC is 90 degrees because this is the longest side. The angle opposite to that is the right angle. Angle ABC is 90. So it's a right triangle. So you can find its area using half base into it. After doing this, don't find the area using Heron's formula. After doing this, don't find the area using Heron's formula. Why did we do this? So that we can use the formula half base into height. Half AB into BC. Half 3 into 4, 6. If you want to use Heron's formula, you need not do all this. Directly Heron's formula. Okay. Then 5, 5 and 4, they don't form a Pythagorean triplet. They do not form a Pythagorean triplet. You can even try. You cannot make out the longest side at all here. See, these two sides are equal. Then definitely it's not a right triangle. If two sides of a triangle are equal, it can definitely not be a right triangle. Am I right or wrong? Okay. So two sides of a triangle can be a right triangle. When two sides are equal, the triangle can be a right triangle, provided the equal sides are, that is, the third side is longer than the equal sides. Provided that the third side is longer than the equal sides. We have a right isosceles triangle, no? Right isosceles triangle. A right isosceles triangle we have. Okay, wherein the legs are equal. And this is the longest side. So that means the base is longer than the legs. I've told you, in a right isosceles triangle, the hypotenuse is called the base. And these two sides, the equal sides, are called the legs. Legs. In a right isosceles triangle, the legs are equal. The hypotenuse, which is the longest side, is called the base of the triangle. Always in an isosceles triangle, the third side, which is not equal, that is only the base. In an isosceles triangle, when you use the term base, it refers to that side which is not any of the equal sides. So which are the two sides equal here? The legs are equal. Legs only have to be equal because the hypotenuse is the longest side. It cannot be equal to anything. That is the base. Base is the hypotenuse in a right isosceles triangle. But here, these two sides are equal, but still you feel it can be a right triangle. It can't, because see, if you take the third side, this is shorter. This is 4 centimeters. These two can be the legs, but the hypotenuse is 4. It can't, it's not possible. So this is not a right triangle. Find its area using Heron's formula and add. Okay. Find the percentage. No, let's come from here. Yeah. Find the percentage increase. This we have finished earlier. I think that's all. We're almost done with Heron's formula. Okay. Yeah. Find the percentage increase in the area of a triangle if each side is doubled. Find the percentage increase in the area of the triangle if each side is doubled. Okay. So you don't know. No. Meaning the sides are not given. You have to find out. Now you have a triangle with sides A, B, and C. Now you have another triangle where the sides are doubled, 2A, 2B, 2C. There is the original triangle with ABC. Okay, let me make it small. There is this original triangle with ABC. Then there's another triangle where the sides are doubled, 2A, 2B, and 2C. Obviously, this area is small. Here the area is meaning more than the earlier one. What is the percentage increase? What is the percentage increase is the question. What is the percentage increase is the question. So see here. See here. First we have this triangle ABC. Then A becomes 2A. B becomes 2B. And C becomes 2C. 2A, 2B, 2C. Okay. Now supposing the area of this triangle is say 100 centimeters square. For example, and the area of this triangle. For example, okay, this the area of this triangle say is some 400 centimeters square. 400 centimeters square. All right. Now, how do we find the increase in area, children? What is the increase in area? Okay, what I'm saying is we have a triangle with sides ABC whose area is 100 centimeters square. We have another triangle whose sides are double of the first triangle, 2A, 2B, and 2C. And we find the area, it comes out to be 400 centimeters square. What is the increase in area? What is the increase in area? Don't know, children? Say don't know, then I can say the answer.
Ma'am, 300 centimeters square.
300 centimeters square is the increase in area. Because what is the increase in area? The new area minus the original area. The increase in area is the new area. Increase in area is equal to the new area minus the original area. 300 centimeters square is the increase. Now, how do you find the increase percentage? They are asking you to find the percentage increase, not only the increase, the percentage increase. So the percentage increase is increase by the original into 100. What's the increase? 300. What's the original area? 100. Increase in area by the original area into 100. Increase in area is 300. Original area is 100 by original into 100. That's the formula. 100 and 100 gets cancelled. So the percentage is 300%. The area is increased by 300%. If the sides are doubled, the area increases by 300%. Similarly here, the side of the triangle ABC, the side of the triangle ABC, a semi-perimeter is S. Okay, so S is equal to A plus B plus C by 2. You know all this. So when you cross multiply, you get A plus B plus C is equal to 2S. Do we understand this, children? This one and this one? Say yes or no?
Yes, ma'am.
Yes, ma'am.
Yes,
Is this
ma'am.
understood? And when you cross multiply, you get 2S is equal to A plus B plus C. Correct?
Yes.
Yes, ma'am.
Yeah. Now tell me, how do you read the symbol? How do you read the symbol?
Triangle.
It's actually like this, but we use it like this in mathematics to read delta. It's a Greek letter, delta. So let delta be the area of the original triangle. It's actually triangle, but we use that, see, in it's situational. It is situational. Now, how do you read this? Read this and this. Read this.
Red.
Red.
This one.
Read.
Read also. Also, you can say
Red.
red. Now, the balloon is red in color. You will write this only, right? The balloon is red in color. You will write this. I already read that book. I already read that book. So similarly here, this triangle symbol, you know, it's situational. So here you will not say let triangle be the area. You will say let delta be the area. So read it according to the situation. Let delta, see, this is commonly used. You can even say let X be the area of the triangle. But see, certain things are conventional. You know, we mostly use like this. So we'll do this. So you can even say let X be the area or capital A be the area. That's your choice. Any letter, any symbol you can use. Let delta be the area of the delta. Let delta be the area of the original triangle. So what is delta then? Root of S into S minus A into S minus B into S minus C square units. Because the sides are A, B, and C. Then what's the area? Original area is this one. We can't calculate further because we don't know the numbers, right? Yes or no, children? Understood till here?
Yes, ma'am.
Yes, ma'am.
All right. Now next is let 2A, 2B and 2C be the sides of the new triangle and S dash be its perimeter. Be its perimeter. Okay, I forgot that it's here. Be its perimeter. Let 2A, because double, the sides are doubled. So let 2A, 2B and 2C be the sides of the new triangle and S dash be its semi-perimeter. See, S is the semi-perimeter here. S dash is the semi-perimeter here. Then S dash is equal to sum of the sides 2A plus 2B plus 2C by 2. So S dash is equal to 2 common and then they get cancelled. So S dash is equal to A plus B plus C. But what is A plus B plus C? 2S. 2S. So S dash is equal to 2S. See here, 2 is common. 2 gets cancelled. So S dash is equal to A plus B plus C. What is A plus B plus C? 2S. So S dash is equal to 2S. Yes or no?
Yes, ma'am.
Yeah. Now we have not still found the area. We've only found the semi-perimeter for the new triangle. We have only found the semi-perimeter for the new triangle. We have to still find the area. So let delta dash be the area of the new triangle. So the area of the new triangle delta dash is equal to square root of semi-perimeter minus minus the sides, the same formula. So square root of what's the semi-perimeter? S dash into S dash minus 2A, understand? Into S dash minus 2B into S dash minus 2C, correct? Because semi-perimeter minus the sides, no? Semi-perimeter is S dash. And the sides are 2A, 2B and 2C. Correct, children?
Yes, ma'am.
Yes,
But
ma'am.
now, yeah, now what is S dash? It's 2S. S dash is 2S. So S dash is 2S. So 2S into 2S minus 2A. S dash is 2S minus 2B into 2S minus 2C. Next, take out 2 common everywhere. See here, there's 2 common here. Between these 2 is common. Here also 2 is common. Here also 2 is common. And it's all multiplication. All multiplication it is inside the, under the square root, it's all multiplication. So square root of, I've written this 2s as it is. 2 is common. So into 2 into s minus a. Into 2 into s minus, see 2 common, 2 common. You cannot put a plus sign in the middle. It's all multiplication. Into 2. Everywhere 2 is common. Into 2, not plus 2. Now there are 4 2's. 1, 2, 3, 4. 2 2's come out of the square root. And the rest of it remain under the square root. This s is there. And then this s minus a. Then this s minus b. And then this s minus c. Of the 4 2's, 2 2's come out. So we get 4 into root of s into s minus a into s minus b into s minus c. So delta dash is equal to 4. What is this one? Delta. See here. What is this? Delta. This is delta. What is this one? What is this one? Is this one? Which is delta. So 4 delta. 4 delta. This is the original area is delta. The new area is delta dash, which is nothing but 4 times delta. So the increase in the area of the triangle is the new area minus the original area. The new area, that is what is in 2 minus 1. That is 4 delta minus delta, which is 3 delta. Percentage increase in area is equal to increase in the area of the triangle by original area of the triangle into 100. So this is the increase 3 delta by the original, which is delta into 100. So delta and delta gets cancelled. 3 into 100 is 300. 300%. Understood, children?
Yes, ma'am.
Yes.
Yes,
Now
ma'am.
these 3 sums, yeah, these 3 sums, all of you have to work. Now earlier most of you have sent the assignment, but I have not still opened it and seen. Today or tomorrow I'll put up the list, children. Those of you who have submitted, I need to appreciate you all. So definitely the list will come up tomorrow. 2 pending and today's also. Separately I'll put up the list. So please complete this sum. The others you may just revise. You may just revise because there's really nothing difficult in that to work. So you can just revise and see how it's calculated. This one, all of you must do it in your notebook. Okay, so you do this now. Now this one. I'm not explaining the 13th one because it's similar to the one which I just explained. Find the percentage increase in the area of the triangle if each side is quadrupled, meaning multiplied by 4. 4 times it becomes quadrupled, meaning 4 times. Doubled as 2 times. Quadrupled is 4 times. So 4A, 4B, and 4C. Same working. Exactly the same. But the sides are, everything is the same. But the sides are 4A, 4B, and 4C. So you need to understand this by yourself. Work this answer. So this is compulsory. All of you, this question number 11, it's already shared on WhatsApp with you, or you can take a screenshot if you want now. This all of you must work. This one all of you must work. This I'll explain now. And this one also all of you must work. Help yourself, all of you must work this. Along with this, I'll give you 3 questions for test. The answers we'll see in the next class. So these 3 answers you should have worked, plus the 3 questions which I'll be sending on WhatsApp. You should work all this and send the pictures with me by today, 10 p.m. today. All right?
Yes, ma'am.
All right. All right, children. Let's understand this one.
Ma'am, can you please show the 3 pictures again?
Okay. This is the first one.
Yes, ma'am.
This is the second one.
Okay, ma'am.
There's a third.
Okay, ma'am.
Yeah. If each side of an equilateral triangle is tripled 3 times, find the increased percent in the area of the triangle. So let A, here is an equilateral triangle. So you don't have to take all the 3 sides. You know, each side is A units. So let A be the original length of each side of the triangle. This is triangle, children, not delta. Okay, I think I shouldn't use the symbol here. I'll make a triangle, okay? Oh, sorry, a delta only this is, sorry. Let A be the original length of each side and delta be the original area of the equilateral triangle. Okay, I didn't read it correctly. Let A be the original length of each side and delta be the original area of the equilateral triangle. Original area of the equilateral triangle is equal to √3/4 into side square. So that's we have called this area as delta. So delta is equal to √3/4 into A square units. Yes or no, children? Understood this? Let A be the side and delta be the original area. What is the area formula? √3/4 into side square. So √3/4 into A square. And the original area we are calling it delta. So delta is equal to √3/4 A square. Now the sides are tripled. So let 3A be the new length of each side. Let 3A be the new length of each side. And let delta dash be the new area of the equilateral triangle. Let 3A, the sides are tripled, so 3A. And let delta dash be the area. 3A is the length of the side and delta dash is the new area. Now how do you find the new area? √3/4 into side square. √3/4 into side is 3A. It's not 3A square like this. The side is squared. See, what is this? The side is squared. What is the side? 3A. So it is 9A square. Don't write the side is squared 3A square like this. That's wrong. Whatever is the side, the entire thing is squared. 3A is the side. The whole thing is squared. So 9A square. √3/4 into 9A square. So delta dash, because new area is delta dash, is equal to √3/4 into 9A square. Now, just have √3/4 A square in the bracket. Just have this √3/4 A square in the bracket. And whatever is remaining, put it outside the bracket. 9 is remaining, put it outside. See here, write this root 3, 4 and a square inside the bracket, root 3 by 4 a square. And what is remaining 9? Put that outside the bracket. So what do you get? Delta dash is equal to 9 into root 3 by 4 a square. Delta dash is equal to 9 into root 3 by 4 a square. But what is root 3 by 4 a square? What is root 3 by 4 a square? Root 3 by 4 a square is delta. So delta dash is equal to 9 times delta. The new area is 9 times the original area because original area is delta. New area is delta dash. So the new area is 9 times the original area. Delta dash is equal to 9 times delta. So what's the increase? So after finding the original area and the new area, you must find the increase in area. See, this is the order. Find the original area, find the new area, find the increase in area, find the increase percent. Original area, new area, increase in area, increase percentage. That's the order. So the increase in the area of the equilateral triangle is the new area delta minus the original area, the new area delta dash minus the original area delta. New area delta dash minus the original area delta. Delta dash minus delta. So it's 9 delta minus delta, which is 8 delta. 8 delta. So now what's the percentage increase in area? Increase in area by the original area into 100. Increase in area is 8 delta. Original area is delta into 100. Delta and delta gets cancelled. 8 into 100 is 800. So the percentage increase in area is 800%. Is it clear, children?
Yes, ma'am.
Yes, ma'am.
All right, children. Okay. So you may think I'm winding up the class 20 minutes earlier. It's not like that. You have to complete the 3 sums. Please work the 3 sums and also the 3 sums which I post on WhatsApp as homework. Okay, so complete these 6 sums and share the pictures with me by 10 o'clock today. And the list will be put up tomorrow positively. Please make me happy by completing the assignment. All right, children. So that's it for today's session. So mostly we have come to the end of, Heron's formula. Let me just check if I have any more important sums to do. So mostly one more class will wind up with Heron's formula and I'll check with you all. I want to start volumes and surface areas, which is a vast chapter and which, is useful for 10th and ahead. So I thought we'll just take more time to do volumes and surface areas because quadrilaterals, I'm not saying is not important, but will not be used much in 10th standard. So I want to spend more time with something which is, carried forward to 10th and beyond 10th. Quadrilaterals also we'll do in detail, but I don't want to start at this point. So let me check with you all what you want to do after Heron's formula. We'll decide that in the next class. But mostly, not mostly, for sure, next class we'll wind up with Heron's formula. All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Thank you.
Um,
Thank you, children. Thank you.